Right, so in front of you, you can see the eddy current retarder. So this is basically the brake on the dyno. So if you remember the old dyno, we had a pair of water brakes which applied the load. This is basically the slightly more modern alternative, or at least what's in basically most of modern day dynos. So it's completely electrical, there's no water involved or anything like that, so a lot more reliable. And also the key advantage is it responds almost immediately to input. And obviously this is because it's just electrically controlled, it's nothing more complicated than altering the input voltage, which can be done obviously by the computer, and the brake will respond very quickly. That therefore means you can basically do power runs and load testing without having to interfere with it at all. The computer will do 100% of the work. You can just, for a power run, you can effectively just set a ramp rate in the software, and the computer will then allow the rollers to ramp up at a certain rate by, you know, adjusting the load on this via PID. So it's a sort of a much more useful and advanced technology, really. Although actually in its heart it's really very simple in respect of how it works. Probably more simple, if anything, than the water brakes. So you'll see there's basically a rotor on each side that spins with the dyno. I should point out at this point, this is actually incredibly heavy in itself. You'll then see there's a series of coils around both sides. These are currently parallel wound. Basically originally it was used on the old Sun system at 24 volt. We're actually going to be changing that because we actually want to run 192 volt, which basically involves series winding it. So what we have to do is disconnect all of the wires, connecting those coils together, and connect them all in series rather than parallel, which will give us the much easier to control sort of lower ampage from the computer interface. So we need to basically, well, we don't need to, but we're going to strip this down, clean everything up, disconnect all the coils, and then while they're disconnected I'm going to go through them one by one to make sure that all of them are still good. For all we know, there could be coils here open circuit, they could all be open circuit and melted or whatever from previous abuse. I've got no idea the history of this dyno. What I do know though is that this eddy brake hasn't been used for a long time. The previous owner was running it as an inertia only unit, so we need to get this working. So obviously a worst case we could have melted coils. They're aluminium windings from what I can see, so corrosion could be a problem. I mean, they look pretty good actually if I peel back the cardboard and look underneath, but who knows what's going on. So the worst case, we could have to buy a roll of sort of cable and rewind this, which will be great fun. But for a minute we're going to get it apart, start testing it, and we'll probably give all the sort of metalwork a paint work and just give it a clean up like we did with the last dyno, really. Obviously going with these bearings, clean all this old grease off and out of the insides of them so we can start from fresh. And then that will get put to one side. That will be one of the last bits that we actually put back into the dyno once it's in, just because it doesn't need to be there till the end and it's just adding more weight. So we're going to largely build the dyno in the hole like we did last time. Okay, so I'm just getting the eddy brake apart now. Looks like Chris is doing a bit of welding. Chris has got the linking out, look out. So I've just pulled off the rotor off one side, so you can sort of see what we got going on here. That was the bearing housing that held it to the dyno frame. The inside part of the bearing there, and then that's the rotor that sits on the end here and spins with the drive flange in the middle, the separate pieces. And here you can see the coils. So you've got 8 coils there, currently connected in parallel. You've got a bearing cartridge in the centre, so I'm going to obviously clean this right up. I'm then going to disconnect all the coils from the connection blocks and then test each one individually to see if we have any that are open, etc. And then if they're all okay, they'll all be wound up in series again. If not, we're going to have to start taking the caps off and basically rewinding them, which is going to be a pain in the neck. And there's the other side off. Much of the same really. Both sides are identical. Some of the connections are interconnected. The connection block in each corner. It's got 2 posts that go right through the centre and 2 that connect to either side, allowing it for sort of series parallel wiring. But we're going to have to modify that slightly, obviously. Right, as you can see, we've made a bit of progress with the dyno in the last few days. The weather has gone absolutely miserable for the time of year. So sure to say the combine is in the shed at the moment. So we're here doing a bit of work here where we can. So we've got the frame, the sort of top cover frame, just positioned in there a minute just to make sure we got our measurements right where we built the block work. Which, the good news is we have, it sits straight in there perfectly and it's dead level. So that's good. So I've just had to leave it there for a minute. I could do with someone else being here to help me lift it out again so I can clean it up and start painting it. So I set aside here some time to start stripping down the eddy brake, which is completely unknown. Whoever used the dyno last hasn't been using it. They've been using it as an inertia only, which generally points towards there being an issue. So the first thing we did was put a meter on it, and sure enough the brake is open circuit, and it's wired for parallel, so obviously that means that it's probably more likely a wiring problem. Well, it could be broken in many places basically, and be doing that. So we decided, rather than piss around with it, to just strip the thing down completely and kind of start fresh with it. So the centre core we took out, so that's got the bearings and everything in it. Move that out of the way. We've then disconnected every single coil, and we've then sort of logically gone through one coil at a time, metering them out, to see if they're still connected, if they're open circuit or whatever, if they're short to ground. We've had a mega here just to sort of testing it to ground with sort of 500,000 volts. None of them are going to ground, which is great. Basically all of them actually test out good. We've actually put them on with load as well, so 12 volt, it's around 10.5 amps. Just left them on for 5 or 10 minutes each until they're sort of just warm. All of them seem to be okay, and they still meter out good afterwards, bar basically a few which we've got problems with. So if you look at this side, you'll notice we've got the stator end plate missing off that top left coil, and also the one on the right there is loose. You'll also notice that the coils look different on them. Someone's obviously had issues with these two coils before and they've had them rewound. The mistake they've made is when they put it back together, they haven't put a gasket or something in the end to keep them tight, which has meant that they've been moving around and they've bust all the wires off, which is basically why the whole thing was open circuit. So we have basically crimped some new wires onto the windings on both of these units, which you can see. They're aluminium core wires or windings, so you can't solder anything, so it's all a crimping job. So we've crimped them. There's also a couple of old existing coils where the wiring or the crimps or whatever had corroded, and we've also, it's a bit dark to see, but we've also had to crimp in repairs to these as well. So we've now tested every single coil, and as of now every single coil is working, which is great news, because we were basically kind of thinking that we were either going to have several coils rewound, or maybe even everything rewound, or even looking at buying a different brake. But it's looking like for the time being this one's going to be more than salvageable. We just need to get some tapered bolts to hold those ends back on, because they were absolutely destroyed from whoever tried to get it off last time. We had to basically chisel them out. So then luckily it's all metric thread M10, so I'll be easy enough to get some new bolts to hold that together. So that's that side of it all together now, basically ready to reconnect everything in series. I just need to sort out the polarity of everything, because you can't see the colour of the wires. So I have to use like a compass or something and connect each one, work out which way they're pulling, because it's very important obviously for your eddy currents that you've got sort of north-south that way, then that way, so that you get your eddy currents forming, which is what that basically induces into those rotors to produce your braking force. So that's that side of it. And so over here you can basically see everything that we've taken apart. So what basically happened was, in the very centre you had this big central core, which actually I thought was greased basically, but it isn't actually. It's actually open bearings with an oil-filled core with two lip seals that sit in the outside. Well, quite evidently this hasn't had any oil for many years. Both bearings are completely dry, rusted out. The outside one is actually sort of still functional, but it's horribly noisy and there's play in it. So I've ordered up 2 new bearings, nice common size, so easy to get hold of. The 2 lip seals, which basically sit in the outer flanges, which are these pieces here, are completely shot. So I've also ordered 2 lip seals, again really easy to get hold of. It's all common sizes, which is a nice pleasant change to be able to get hold of parts so easily. So there we've got basically the shaft that runs through the centre, really nice piece of machining going on there. 2 sealing rings for the lip seals to seal on there. That's the bolts that hold it into the centre. So this is your 2 end flanges, which the bearing sits in, and I've just messed all of my hygiene up, but never mind. The lip seal sits in the end of that, the bearing sits on the inside, that keeps the oil in, so that centre cartridge remains full of oil. And we've got the same for the other side, and obviously here you can see the 2 rotors, the drive shafts and the bearings, which all needs cleaning up yet. So basically that's all of that taken apart, pretty much waiting for parts now to put that unit back together and then rewire it, ready to put back on the dyno when it's all finished. Right, Chris is on a bit more cement here. We've been filling around the outside of the pit, just to level things up, make it look a bit tidier. Chris is now just working his way along the back. There's quite a big gap back there. I'm down here. I've just wire wheeled on the grinder all the top covers here, so they're all nice and rust free and grease free, etc. now. So they're going to get a coat of paint, as they are. As are those covers that you can see there. They need to be wire wheeled yet, I haven't done that. And then there'll be some other bits and pieces to paint up as well, but we'll get this lot done here first. Looks like we've got a intricate building support being utilised here, Chris.